All right, guys. Good morning, everybody. Hope you guys are doing well. I wanted to start off today's video by answering some questions that I've been receiving over the weekend. The two most frequent questions that I've been asked are, one, are we going to go back to school? And two, is there going to be an ACP? And the honest answer to both of these questions is I have no idea. I can tell you that as soon as I do hear about either of those two things, I'll be sure to post it immediately and let you guys know. But that is the truth as of right now. So we're going to keep doing the homeschooling thing. I can tell you that if you need a laptop, if you don't have one, you can still pick one up from the school. They're doing pickups today from 9 to 1 in the back of the school by Bo Bison, and from 1:30 to 3 in the front of the school. So if you need a laptop, just go to Sunset today. The other thing is about your makeup work. All of the makeup assignments are underneath that makeup work tab. If you just go to my Google Classroom, go to classwork, there's a whole section that says makeup work, and there are all of the codes for the quizzes right there. If you've already done them, I'll be putting in those grades right after I finish making this video, so just be on the lookout there. Yeah, okay, great. All right, well, let's jump into today's lesson. Today, we are going to review, all right? So we are going to just look at series and parallel circuits and kind of take a step back and go back and revisit electricity and just sort of have a nice little review day before we move into electromagnetism, which is the next little bit of this. Okay? All right. So things to remember. All right, here we go. So we have two types of circuits. We have series circuits and parallel circuits. All right? If you remember, a series circuit looks like this. There's a battery and it goes in one loop, right? So if you have multiple resistors, all of them are in one single loop, whereas if you have a parallel circuit, okay, you have multiple loops, okay? So the first thing you should do whenever you see a circuit is identify if it's in series or parallel. If it's in one loop, it's a series circuit, and if there is more than one loop, it's a parallel circuit, all right? And then you got to remember about the voltage, the current, and the resistance. So in a series circuit, the voltage drops, meaning that every resistor, every light bulb that's in that circuit eats a little bit of that voltage, okay? The current is the same everywhere, all right? Now you may be asking, why did I draw this in red? That's because this is how I remember the difference between the two. I remember that current is an I, all right? And you don't even have to remember that. That's on your equation sheet, okay? And I remember an I is a 1. It looks like a 1. It forms one single straight line. So I remember that a series loop is only one loop. A series circuit is just one big loop. So I remember that in series, okay, the current is the same everywhere, all right? And the resistance, again, this is on your reference sheet, the resistance in series just adds up. So the total resistance is the first resistor plus the second plus the third plus however many others, and that's it, okay? In a parallel circuit, okay, I remember that it's the voltage that's the same everywhere. How do I remember that? Well, parallel circuits have many loops, which means that they split, which looks a lot like a V, okay? So I remember that in parallel, the voltage is the same because parallel circuits split, like right there. Does everybody see where it splits and forms two different loops, or three different loops, or 100 different loops, okay? Which means that the current drops, okay? Meaning that whatever the total current is, each resistor eats up a little bit of that current, okay? And that all of the currents at each resistor add up to the total. And then last but not least, everybody's favorite, I'm sure, is that the resistance is the reciprocals add up, okay? Which again, this is on your equation sheet, but it's 1 over the total resistance equals 1 over the first resistor plus 1 over the second resistor plus 1 over the third resistor. Good, cool. Okay, so I'll leave this here for just a second. You can pause this. I recommend writing this down. Okay, as we go forward, we're gonna do a couple examples, and then I'll let you guys be on your way to do your review quiz for today. All right, let's look at some examples. All right, so let's look at some series examples first. The first one is going to be very simple, okay? Let's start off with a very easy one. So we're gonna have our battery here, and we're gonna have 2 resistors. How about that? Make this nice and easy for Monday. The first resistor is gonna be 10 ohms, the second resistor is gonna be 20 ohms, and the battery is gonna be 90 volts. All right, perfect. So there is my circuit. I have a 10 ohm resistor, 20 ohm resistor, 90 volt battery. I know that this is in series because it's one big loop. All right, whenever you get a circuit, first thing we gotta do is make a chart. And that chart goes V, I, R in that order, all right? We label each resistor. So I have 2 resistors. So I go R1, R2, and then last but not least, I have space for the total. And then I draw my first lines of the week. Not terrible. And I have my chart. Okay, so now we're gonna write down what we know. Well, I know the battery has 90 volts, which means that that is my total voltage. And I know that my first resistor, okay, is 10 ohms. And my second resistor, because remember, we always go clockwise, right? Is going to be 20 ohms. Okay, so this is everything we're given. Okay, take a look at it for a second. What are you feeling? What do you think you should do first? Pause the video if you want to go ahead and solve this, okay? All right, let's see what you got. All right, so first thing we're gonna do here is find the total resistance. And that's easy. All we gotta do is add up the resistors. 10 plus 20 is 30. So 30 ohms is my total resistance, okay? Now, remember, any row where there's 2 numbers filled in, you can find the third, and that's because voltage equals current times resistance. That's why we use the chart, all right? So that means, if I pull this down here, that 90 equals the current times 30, all right? So if I want to find I, okay, this is multiplication, so I just divide both sides by 30. 30 divided by 30 is 1. 90 divided by 30 gives me a current of, you guessed it, 3 amps. Boom. All right. The next thing we got to do is I know that if the current, the total current coming out of the battery is 3 amps, I know that because this is a series circuit, okay, there's one loop, and that I looks like a 1, that the current is the same everywhere in series. Which means this is 3 amps, and this is 3 amps, right? The current is the same everywhere in a series circuit. Now, all I have to do is I have 2 numbers in each row, so I just have to multiply them out. So I have resistance times current equals voltage. 10 times 3 is 30. 20 times 3 is 60, okay? I can double check everything. My voltages need to add up, so 30 plus 60 is 90. Check. All my currents are the same, 3, 3, 3. And 10 plus 20 is 30. Go across each row, they all multiply out. Voila, everything I need to know. Cool? All right, let's do one more series example. Okay, let's make this one a little bit more challenging. Let's do this last one here. Okay, so for this last one, we're gonna have a 40 volt battery. We're gonna have our first resistor, R1, which we don't know. Our second resistor, R2, which I know the voltage of, which is going to be 10 volts. And a third resistor, which is going to be 10 ohms, and the voltage is going to be 20 volts. Okay? All right, a little bit different than the first one, a little more challenging. That's a good thing. Okay, so same thing. It's a circuit. First thing we do is figure out what kind of circuit it is. Obviously, there's only one loop. Okay, these are just labels. Those aren't loops. Okay, so this is a series circuit. So I'm going to make my chart. V, I, R. And I have 1, 2, 3 resistors, or 3 light bulbs, or 3 cell phones. Whatever it is, that is plugged in. I got 3 of them. Okay, there we go. All right, I can put a line right here. Okay, so step number 1, write down what we know. Well, we know the battery is 40 volts, so that gives us a total voltage. Again, stop the video here. Go ahead and see if you can solve it yourself. Turn it back on and see if you're right. Pause. Continue. All right. I don't know anything about the first resistor, so I got nothing in that first column. The second resistor, I don't know the resistance, but I do know the voltage is 10 volts, so I fill that in right here. Okay, I know that that second resistor has 10 volts, right? The third resistor, R3, okay, which I can label right here, sorry. Okay, R3, I know is 10 ohms of resistance, so I know the resistance, 10 ohms, beautiful. And I know it has 20 volts, so I know my voltage, okay? Oh no. Wrong resistor 3, yes, sorry. 10 ohms, and I know that it is 20 volts. Okay, where to start? Well, there's actually 2 places that we could start here. The first one is we have 2 numbers in a row. Wherever there's 2 numbers in a row, we can find the third. So I can find what my current is right there, okay? So again, voltage equals current times resistance. So here I have 20 equals I times 10, right? I want the I by itself. This is multiplication, so I do the opposite, which means I divide both sides by, you guessed it, 10. Boom, boom. 10 divided by 10 is 1. 20 divided by 10 gives me an I of 2 amps. Very good. Another way of saying that is what times 10 is 20? And the answer to that question is that 2 times 10 is 20, right? This is a series circuit. It has 1 loop, which means that the current, the I, is the same everywhere. So that means that the first resistor gets 2 amps, and the second resistor gets 2 amps, and the total resistance is 2 amps. Beautiful. And then from here, we can figure out the rest, okay? Here at the bottom, I have blank times 2 is 40. So again, if you need to write it out, okay? So R times 2 is 40. If I want to get R by itself, I have to do the opposite of multiplication, which is division. So I divide both sides by 2. 2 divided by 2 is 1. R equals 40 divided by 2, which is 20. So my total resistance is 20 ohms. Okay? Up here, I have 10 volts. I have 2 amps. What times 2 is 10? Let's do it a little faster this time. The answer to that is 5. If you want 10 bucks, you need to have 2 5s, right? Okay? And then lastly, oh, I'm missing these 2 spaces. But we know that voltage adds up, right? And resistance adds up. So look at your total voltage. My total voltage is 40. This is 20. This is 10, which means 10 plus 20 is 30. What plus 30 is 40, right? Well, 40 minus 30 is 10. And then over here, my total resistance is 20. I have 10 ohms and 5 ohms. 5 plus 10 is 15. Okay, and 15 minus 20 is 5. Double check everything. 10 plus 10 plus 20 is 40. 2's all the way down my current. My resistance, 5 plus 5 plus 10 is 20. 5 times 2 is 10. 5 times 2 is 10. 10 times 2 is 20. 20 times 2, 40. Everything works out. Lovely. Okay? All right, so there are your series examples. Let's do one in parallel, okay? So the first one, we'll make it nice and easy. We'll have 1 battery, which will be 24 volts, and we're gonna have 2 resistors here. The first one is going to be 12 ohms, and the second one is going to be 24 ohms. All right, again, I apologize for my horrendous drawing, okay? We know that this is a series circuit because if you use your imagination, you can see that it's 2 loops. Okay, there we go. All right, 1 loop, this is supposed to be a resistor. 2 loops, this is supposed to be a resistor. All right, There's your battery. So, same thing. We make our chart. V, I, R. I have two resistors. Resistor 1, resistor 2, and the total. Draw my lines. Ooh, going crazy with these lines. There we go. All right, lovely. Chart. All right, write down what you know. My battery is 24 volts, which means my total is 24 volts. Okay? My first resistor is 12 ohms, so the resistance is 12 ohms. My second resistor is 24 ohms. Second resistor is 24 ohms. Okay, now, how do we solve this? Some of you may be looking at this, and you can pause it, see what you get. Some of you may immediately go and add up the reciprocals to find the resistance. And you can totally do that. 1 over the total resistance equals 1 divided by 12 plus 1 divided by 24. Okay, and you can solve for RT. But the reason I like these charts is you don't always have to. Okay, and that's because if we remember, okay, what is the same in all parallel circuits? Well, in series circuits, right, the current's the same, right? One line. Series is one loop. The voltage is the same in all parallel circuits. So what that means is I know that if the total voltage is 24 volts, the voltage over the first resistor is 24, and the voltage over the second resistor is 24. Isn't that easy? And now look at this. I have the same thing. V equals I times R. Well, what times 12 equals 24? Very good job. 24 divided by 12 is 2 amps. Huh. And I have 24 amps and 24 amps. Well, what times 24 equals 24? The answer to that question is 1. 1 amp equals 24, okay? 24 times 1 is 24, okay? Or 24 divided by 24 is 1. Now, here, my currents add up, right? Parallel, voltage is the same, current adds up. 2 plus 1 is 3. And then last but not least, I know that the current times the resistance has to equal the voltage. So 24 has to equal 3 times the resistance. This is multiplication, so I divide both sides by 3. 3 divided by 3 is 1, and 24 divided by 3 is 8 ohms, which is the exact same answer. If you plug 8 ohms into this equation right here, the two sides of this equation will be identical. All right? Good, right? Easy. All right, let's do one more. Parallel practice. Okay, let's do a trickier one. All right. So let's have a battery. All right, so we got a battery, unknown voltage. I got my first resistor. All right, let me draw it like this. Battery, unknown voltage. First resistor is going to be 10 ohms. Okay. Let's do, yeah, that's the same. Okay, we'll do this one. And then the second resistor is going to be 15 ohms. And I also know that the voltage over the second resistor is 30 volts. Okay, so there we go. So I got a battery. I don't know what kind of battery it is. One resistor is 10 ohms. The second resistor is 15 ohms. The third resistor is 30 ohms. Again, I apologize for the handwriting. All right, we make our chart, V, I, R. I write down, I have two resistors, so I have R1 and R2. Again, this is just a label, okay? It's a kind of, in the example problem, it's circled. It says that's 30 volts. That means that this resistor is 30 volts. Okay, so I have a total. All right, made it a little bigger this time. All right, write down what we know. I know my first resistor is 10 volts, or 10 ohms. I know my second resistor is 15 ohms. and I know that the voltage over my second resistor is 30 volts. Okay, a little different, all right? But if you remember, this is a parallel circuit. There's 2 loops. That means it splits. See how it splits right there? It splits into multiple loops. Because of that, I remember the voltage is the same everywhere, which means that this has got to be 30 volts and this has got to be 30 volts. Okay? Once you figure that out, you have 2 numbers in each row. What times 10 is 30? Okay? Well, 3 times 10 is 30, which leads me to the second one, because V equals I times R, right? What times 15 gives me 30? Well, 30 divided by 15, right, is going to be 2, all right? So I fill in those 2. My current adds up because my voltage stays the same, which means the other one has to add up. So 3 plus 2 is, you guessed it, 5. And then again, I have 2 numbers in the same row. So I have 30 equals 5 times the total resistance. To get that, I do the opposite of multiply, which is divide. So I divide both sides by 5, and this gives me a total resistance of 6 ohms. And again, if you go back, 1 divided by 6 is equal to 1 divided by 10 plus 1 divided by 15. Just put that in your calculator, and you'll see the 2 sides of that equation are the same. All right? Okay. How are we doing on time? Let's see here. All right. Okay. Well, I think that's good for today. I am going to be posting the, it's a DOL for today. It's a little bit longer. It's like 24 questions, and it's just a review. It goes over electrostatics or static electricity. It goes over circuits, and it goes over Ohm's law, which again, all you got to remember about Ohm's law is this right here. And the way that it's usually written, the way that it's written on your equation sheet is like this, which is current equals voltage divided by resistance. That's Ohm's law. So just how to use this. Remembering what each letter represents. V is the voltage. That's the total number of electrons that are moving. Okay. Current, I, is how fast those electrons are moving. And R is resistance, which is what is slowing down the flow. Remember, if it's a river, voltage is how much water's in the river. Current is how fast the river's going, and the resistance are the rocks in the river. I get this because if I multiply both sides by R divided by R is 1, and this gives me voltage equals current times resistance. And again, that is horrendous handwriting. I have the whiteboard. I will be putting it up. I just wanted to get this video posted early today. So the next video you see, unless something goes completely wrong, there should be a larger whiteboard. But yeah, jump in there. Remember that electricity is just electrons jumping from one atom to another. Remember that an atom never gains or loses protons. If they do, they become different atoms and you have nuclear explosions taking place. So electrons jumping. If an atom gains electrons, it's gaining negative particles, so it becomes more negative. If an atom loses electrons, it is becoming more positive. Again, all my PowerPoints are posted, so if you need to, just take a second, open up the old PowerPoints and go through them. And again, if you have any questions, please email me. All right? Good luck. Get your DOLs done, and yeah, have a great rest of your day. All right, guys.